Hi, my name is John, and this is for one of my students who goes to Westlake High School for our math analysis honors. Okay, so I wrote down, there was about 13 of these. I only wrote down 10 of them, and we'll be reviewing these as much as possible today. Okay, convert degrees to radians and vice versa. Solve problems involving DMS, degrees minus angles form. Find the trig functions in fractional form when given a point that is terminal that passes through it. Use the calculator to find the 6 trigonometric functions of an angle. Find the trig functions, blah, blah, blah. And these are 10 of the 13 can use from the teacher. So let's go through the first page. I wrote down the first 3 problems. Find the terminal functions, blah, blah, blah. So let's go through them as fast as possible. Convert degrees to radians and radians to degrees. I'm going to give you one. 7 pi over 4. This is in radians because there is no degree symbol here. To do this, you have to use stoichiometry. The conversion factor is, since the radians is in the numerator, you have to put radians in the denominator. Cancel those out, you have to put degrees here. We know that 360 degrees is equal to 2 pi radians. I'm going to put R for radians. I'm not going to use R anymore because if there's nothing there, that means it's popping radians. So to go from 360 to 2 pi radians divided by 2, 180. Half of 360 is 2's cancel. You have to put pi radians. So we put radians pi right there. We put 180 degrees right there. If you notice that the radians cancels, the pi cancels, and 4 goes into 180, that's going to be 90, 45. And so you end up with 7 times 45, 45, 90, 135, 180, 225. That's going to be 225 degrees. Whoop, there it is. Pretty simple, huh? There you go.
That was easy.
The easy button. Okay, so how do you go from, you went from radians to degrees, how do you go from degrees to radians? It's the same thing. Let's try 210 degrees. So first thing we do is we have to put over 1. 7 pi 4 over 4 is already a fraction. Degree goes to the bottom to cancel that out. 180 now is equal to pi radians, right? And so you end up with canceling those degrees out. The 0 in the back cancels, dividing by 10. 21 and 18 goes into 3 times. 21 goes into 3 times 7. 21 goes into 18, 6. So it's going to be 7 pi over 1 times 6 is 6 radians. And by the way, you should know that pi over 6 is equal to 30 degrees, and pi over 3 is equal to 60 degrees. Easy way to memorize this is your family. 6 and the 3 interchange always. Notice that 3 and the 6 are always interchange. So if it's pi over 6, it's going to be 30, correct? And then you multiply that by 7. What is 30 times 7? 30 times 7 is, drop your 0, 3 times 7 is 210. And whoop, there it is right there, 210 degrees. So we checked our answer, okay? Solve problems using angles in DMS. I picked one for you. 27 degrees, 18 minutes, and 12 seconds, okay? Oh, sorry about that. So how does it work? You go from degree, minutes, seconds to decimal form. You cannot use this when you're trying to calculate things out. So what we do is there's a little trick. We divide this by 60 to change it into decimal. And we divide by 60 times 60, which is 3,600. And then we just add them. Let's see. 27 plus 18 divided by 60 plus 12 divided by 3,600. And we end up with 27. Nope, that's not quite right. Should have been, let me see. Oh, this is 28. I miswrote the question now. Should have been 28 right there. Let's try it again. 27 plus 28 divided by 60 plus 12 divided by 3600. And 27.47 degrees. That's equal to 27.47 degrees. Now you're in decimal state. Well, how do you go from let's say a decimal state to a DMS state, degrees, minutes, seconds? You take the 27 right there, we add 0.47 times 60 is the inverse operation of dividing by 60. There are 60 minutes and 1 degree, 60 seconds and 1 minute, right? So we take 0.47 times 60 is 28.2. And so that's going to, this whole portion right there, that's the 28 minute. Now we take the 0.2, we multiply by 60 again. You end up with 12. And that's equal to the number of seconds. So you take the decimal state, you take the 27, the whole fraction, the whole number portion, just 27. You take the decimal, multiply by 60. Whatever the whole number is, that becomes your minute. And then you take the fraction of that, 0.2, multiply by 60 again, and you end up with 12 minutes. Let's try this. So if we have 27.47, that's in decimal state, right? Let's say we want to do that and change it into DMS state. What we do is we go to second, and above the app, there's the angle right there. Oh, you notice that right there? There's a DMS state right there. Boom, there it is. That becomes 27 degrees, 28 minutes, 12 seconds. 27 degrees, 28 minutes, and 12 seconds. There it is. You cannot go from a DMS state to a decimal state, because when you go into the angle right there, there's a degree symbol, there is a minute symbol, but there is no second symbol. So therefore you cannot use seconds. Okay. All right. And this one's going to be a little bit hard, so I'm going to use a different paper on this. Let's say find the trig functions for a fractional form when given a point that its terminal side passes through 3 comma negative 3 comma 4. I'm going to do it on the back here. It goes through negative 3 comma 4. That's your x right there, and that's your y coordinate right there, right? Correct? So there's your x, negative 3 in the x direction, and y, 4 in the y direction. Negative 3 and then up 4. And it starts off at 0, 0 and it goes towards this way. So this is your angle right there. It terminates here along this, and that's your angle theta. Well, we know that this right here, this is your x direction, this is your y direction, this must be your r direction. Oh, do you notice something? It's a right triangle, so it's going to be x squared plus y squared is equal to r squared. How do we solve for r, the radius? You just take the square root of that. Remember that this does not equal square root of x squared plus the square root of y squared. It does not equal that. You have, because you're adding right here. Okay, you have two different terms. If you're multiplying, yes, then that equals square root of x squared times square root of y squared. But since we're adding two terms, we cannot change it to a two partial fractions or two partial roots. Okay, so you have some things to memorize. The sine of the angle is equal to opposite, which is y over r. Cosine of theta is equal to x over r. the tangent of theta is equal to y over x. Opposite over adjacent. I'm going to just rewrite this so that it's in first quadrant. You can see things better here. So you have in first quadrant right there. Here's your x, here's your y, here's your r, and here's your angle theta. So sine of theta is opposite over adjacent. I'm sorry, opposite over hypotenuse. So TOA, right? Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. These are your three from SOHCAHTOA. Okay. Now, the reciprocal function, the reciprocal of sine is cosecant of theta is equal to, reciprocate that, r over y. Reciprocal of cosine is the secant of theta, which is, reciprocate that, r over x. And the reciprocal of tangent is cotangent of theta, which is equal to x over y. Memorize these will be on your exams. Okay? So, using this right here, r is equal to the square root of x squared plus y squared is equal to square root of negative 3 squared. That's the negative 3 right there. And then plus 4 squared. 9 plus 16 is equal to root 25 is equal to 5. So your r is equal to 5. Let me just plug it in here. That means the sine of the angle is equal to y, which is 4 over 5. Cosine, let's do the reciprocal. The reciprocal of sine is cosecant of theta is equal to 5 over 4. The cosine of angle is equal to negative 3 over 5. That means the secant of the angle is equal to negative 5 over 3. The tangent of the angle is equal to opposite over adjacent, which is opposite, which is 4 over negative 3. I like to put the negative in the front. And then the cotangent of the angle is equal to the reciprocal, which is negative 3 over 4. Okay, and that should answer a lot of your questions. Given this, you should be able to find your 6 trig functions. Okay, that was the trig function in fractional form, I believe. Okay, so, oh, by the way, just to let you know on this one right here, there are 2 Pythagorean triples that you should know. 3, 4, 5, and 5, 12, 13. 5 squared plus 12 squared equals 13 squared. Okay, it will be on your exams. All right, so let's go to the next one. It's probably going to take a little bit of time, so I probably will do part 1 and part 2. Okay, use the calculator to find the 6 trig functions of an angle. Here's an example for number 1. Find cosecant of 20 degrees, right? Well, to use the calculator for this, we don't have a trig function for the cosecant. We only have sine, cosine, and tangent. Make sure when you go into your mood right here, you're in the degree mood, okay? So make sure that you're in degree mood before you start. So what do we do? We know that this is the reciprocal of sine. So we go 1 divided by sine of 20 degrees. And let's just make sure, 1 divided by the sine of 20 degrees. And 2.923, 2.924, approximately 2.924. And that's your answer. You should be able to do with the cosine or the secant and the cotangent as well. On number 2 right here, it says find the trig function special angles in fractional form. I believe when it says special angles, it's either the 30, 60, 90 or the 45, 45, 90. Okay, so let's start with the 30, 60, 90 first. What we like to do is start off with an equilateral triangle here. Draw it nice and big for you. Okay. What is the measure of all three of these angles when it's an equilateral triangle? Well, we know that equilateral triangle, all angles of any triangle has to add up to 180 degrees. And we divide it by 3, that's equal to 60 because everything's equal. So this is 60. And we draw it right down the middle here. And this is the right angle. We know that this is going to be how many degrees? Just think about it. It should be 30 degrees. Let's call this distance x. Then what is this distance? Let's think about that. What is that distance equal to? Because this is x, this distance is x, right? These two right here has to equal x. Since it's an equilateral triangle, this is 2x. And using the Pythagorean theorem, we know that this is equal to x root 3. So let's try a problem out. Let's try a little bit difficult problem out. We know that this is the bigger angle. This is the smaller angle. If this is going to be 6, what is this and what is that? Well, we know that, let's draw it out. 6 is equal to x root 3. Solving for x, what do you get? 6 over root 3 because we divide by root 3 to both sides. Rationalizing that, we multiply by root 3 over root 3. You get 6 root 3. What's root 3 times root 3? 3. Simplifying that, you end up with 2 root 3. That's going to be 2 radical 3. There it is right there. How do you find what this is? This is twice the short leg. So the hypotenuse is twice the short leg. Notice that right here? It's a short leg. And the hypotenuse is twice the short leg. So if this is 2 root 3 multiplied by 2, you get 4 root 3. Remember, 2 times 2 root 3. 2 times 2 is 4 radical 3. Okay? Hopefully that solves the 30, 60, 90. What about the 45, 45, 90? We actually do like this, where this is a square. If this is x, then this is x, right? You end up with 45 degrees here and 45 degrees here. So if this is x and this is x, this is going to be x root 2. So let's draw this out. So I'll give you an example. If this is 10, what is this length? That's equal to x root 2. Solving for x, we divide it by root 2 to both sides. This cancels. X equals 10 divided by root 2. We rationalize the denominator again. End up with 10 root 2. 10 times root 2 over 2 times root 2 times root 2 is 2. Simplifying that fraction, you get 5 radical 2. Okay, so this length is going to be 5 radical 2. We're going to do arc length and English speeds a little bit later on, maybe. I don't think I have time for this. Determine which trig laws to use in solving a triangle and how many solutions will exist. I'm going to do this on the back right here. And it isn't too difficult once you know which ones to use. The law of signs says it's going to be sine of big A over little a is equal to sine of big B over little b is equal to sine of big C over little c. You could reciprocate this, and so it becomes a over sine of a, b, which is equivalent to sine of b over b, which is equal to c over sine of c. So we could reciprocate all of them. And of course, here's a triangle. A, B, C. Angles are for the big letters, and the small letters. Opposite side is little a, opposite side is little b, opposite side is little c. And so that's the law of signs. This is for non-right triangles as well as right triangles. So it doesn't really matter which one you use for right or non-right triangles. The law of cosines says c squared is equal to a squared plus b squared. Notice that kind of like how it's like a Pythagorean theorem right there. Minus 2ab times cosine of big C. Okay. of course, you can do the same thing for b squared. A squared plus c squared minus 2 times a times c times cosine of big B. And you find out what a squared is. You can do that on your own. Anyway, so which one's an easier formula? Well, you notice that law of sines is a lot easier formula to use than the law of cosines. So when do we use the law of sines versus law of cosines? For an ASA situation, angle side angle, you're going to use law of sines. The opposite of that, when you have an SAS situation, you're going to use the law of cosines. When we also use law of sines, you can use it for AAS situation. For this one, you only have side, side, side. There's only two for law of cosines. The law of sines, there is one more, is the ASS situation. I'm going to put this in asterisk because you can't say this. It's a bad word. So do you remember in geometry, 9th grade, 8th grade, when you took honors geometry or geometry, where this was not allowed? Unfortunately, it is now because this is what's called the ambiguous case. What does the word ambiguous case mean? Ambiguous, when I ask all of my students, they don't usually know what ambiguous means. It means something that's unclear. So anything that's unclear is called the ambiguous case or the unclear case. This is where you can have two triangles, one triangle, or zero triangle. There's no three triangle case. So when you use an SSA or ASS, you're going to be finding the ambiguous case. And you're going to use law of sines to even see if you can make one triangle or not. Okay? I'm going to stop here for now and then do part 2 because it's over 20 minutes already. Maybe the last section will be another 10 minutes. Thanks. Bye.